Okay, today we're going to start getting into circles and the different types of lines and segments that are formed or made in circles. First of all, let's define or give you a definition of a circle. A circle is a object whose boundaries go around a center. Well, what is the distance around the circle called? I'll give you a hint. It starts with a C. It would be the circumference. So this first part of the definition is talking about the circumference of a circle. It's the part that goes around the center, right? So that is the circumference. Okay, and then there is the center of the circle. For instance, in this circle right here that I drew the arrow with, this circle would be named circle P, by the capital P, named with that point in the center. It can't just be any point randomly, it has to be a point in the center. And the center, what makes a point be the center is equidistant at all points. It's equidistant from the circumference. And what is that thing that is equidistant all the way around? For instance, when I start here from P and touch the edge, I touch here, I go there. Wherever I start from the center and I touch an outside edge, it's the same distance. It's equidistant. Well, that would be the radius. But the center, that's, first of all, that is how you name a circle. You name it by its center. And also, the center of a circle, that point, is from the center. It's equidistant to the edge. Okay. Next, you have radius, and you guys should be familiar with the radius. But the radius, that's what we were just talking about from the center of the circle. The radius, though, it's half the width of a circle. Okay, it's half the width, and for you to have a radius, it must have one point at the center. So one point at center, and the other point touching the edge. Okay, for instance, here, when I draw this new blue line up here from point P, it must start at P, and then it's going to touch the boundary or the circumference of the circle. That's a radius. It's half the distance. Okay, I'm going to go ahead and skip down to the radius, or excuse me, to the diameter, because again, that's something you guys should already be familiar with. But the diameter, if the radius is half the width of a circle, well, the diameter is the whole width of a circle. It's the whole width. Okay, or it's two radiuses, or two radii is really the proper term. But for you to have a diameter, it has to meet a couple of conditions. First of all, let's look at this diameter to the right, okay, that's written in blue, talking about in this circle right here. Okay, they have this diameter. Notice it touches this edge of the circle, it touches this edge of the circle, and it goes through the circle, through the center. It must go through the center, and it touches the other edge. It's the whole width of the circle, where the radius is just half. So that's why it takes two radiuses to equal one diameter. Well, here's some new ones. The chord. Okay, and I want to kind of circle chord and secant line. Really, a chord and a secant line are one and the same. Okay, and you'll get what I mean here in just a little bit. But we'll start with a chord. For a segment to be a chord, first of all, notice I said the word segment. because a chord is a segment. Okay, it's a segment. For an object to be a chord, all it has to do to meet the conditions of a chord is it must have two endpoints, and I'm abbreviating here, two endpoints on the circle. For instance, look at the green chord right here. Notice it has one endpoint right here, and it has the other endpoint right there. That's all it has to have. It doesn't have to go through the center. It can, but to be a chord, all it has to do is have two endpoints on the circle. Really, in this circle right here that we've been dealing with, and I'm making the blue arrow, okay, isn't there two chords drawn? Okay, we have the one right here that I'm circling in blue, okay, and then isn't the diameter, by definition, isn't the diameter also a type of chord? Because a diameter doesn't have two endpoints on each side. So the diameter can also be a chord, because to be a chord you just have to have two endpoints that are touching the edge of the circle. Well, in the beginning I talked about that the chord and a secant are really one and the same, because all a secant is a line that has two points on a circle. Okay? Remember what a line does. A line, for instance, look right here where I'm circling in blue. Notice that they start out, this is a secant line, but when they talk about that being a secant line, they're talking about only this endpoint right there in red and that endpoint right there. That is what is the secant line. And then all the points that continue to go, because remember when we talk about a line, we have arrows at each end that are going in all directions. But this part right here, the part in between, isn't that also a chord? So a secant line can also have a chord with it, because a chord is just a segment. It's the distance between the 2 points. A secant is the 2 points, the segment part, or the chord part, with the stuff that's going through the points continuing going, because that's what a line does. Okay? And we'll scroll up a little bit. And then you have your next type of line, and that's called a tangent line. All you have to be a tangent line touches a circle at one point. On a circle. And I'm going to circle that because that's important. A tangent line only touches a circle at one point. For instance, right here, they have a tangent line, and I'm going to underline the line that I'm talking about right here. This line here that has point A and point B on it, that is a tangent line, because this tangent line is only touching the circle at point B. Okay? And that is the point of tangency. The point of tangency is the point of a tangent line that touches a circle, because that's the one point that touches the circle, and it's on the tangent line, and that's called the point of tangency. Okay? So we're going to identify, we're going to do some of this together, but in the directions here, in example 1, it says identify the segments of lines. Tell whether the line, ray, or segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle C. Notice how they named circle C. They named it with the little symbol of a circle, and then the letter C, because that's the center. So the first thing I talk about is AC. Well, first of all, look at the symbol. That symbol represents a segment, and it's just starting at A, point A, and it's going to C, the center. Well, isn't that just the radius? So this first one is a radius. Okay. Let's go ahead and go to B. Well, B is AB. Let me use blue. AB, well, here's A again, and there's B again. Well, now that A and B are 2 points that are on the circle, so yes, they could be a chord, but isn't A and AB, isn't that segment more than just a chord? Because when you start at A, you end up going through the center C to AB. Well, isn't that a diameter? AB is a diameter. All right, and let's go to C. C is, yeah, they give me the 2 points, DE, but look at the symbol for DE. Look at this symbol right here. What is that symbol that's above the points DE? That's right, they're talking about the ray DE. So they're talking about starting right here at point D, going through B, through E. And so that's our ray. Well, that line, it's only touching the circle at B. It's only touching at one point. So what does that make that ray DE be? Well, is it a radius? No, because a radius has to be half the width, touching one point, the center of the circle, and the point on the circle. It's not a chord. The only thing it can be, because it only touches the circle with one point, is it's a tangent line. Okay, and then our last one, they use the points AE, and look at the symbol with AE. It's the line symbol. So we look at A and E. I'm going to switch to red. There's point A. Okay, and here's point E, way out here. Okay, well, as this line starts at A, well, actually it starts before you get to A, but as this line goes through A, okay, and then it goes through E, or excuse me, G, and then it goes through E, and it continues to go on. Well, there's 2 points on the circle, but the line continues to go in both directions, so that is an example of a secant line. Okay. All right. So what I would like for you guys to do is I'd like for you to do monitoring progress, example number 1 and number 2, and to answer the questions that they talk about in number 1 and number 2 is you're going to use this diagram up here, okay, to answer the questions. So do those 2 problems. When you're finished, raise your hand and have the substitute come by and look and see if you did it correct, answered it correctly. And if you get stuck, raise your hand and the substitute will be able to get you corrected. All right, so we're moving on to the next page. Going to kind of talk about some things with circles. Coplanar circles. Well, first of all, we've had this term, coplanar, already this year. First of all, the first part, co, means that they're sharing something, and planar means plane. So what we have is we have something that is sharing the same plane, and since we're talking about circles, it's just circles that share the same plane. Okay. Now, the next one, tangent circles. Well, let's think about what tangent meant. What did it mean when we had a tangent line of a circle? What was the definition of a tangent line? Well, we defined a tangent line as a line that touches a circle at one point. So for circles to be tangent circles, doesn't that mean the circles touch at one point on the outside edge? Okay? So this circles touch at point of tangency. Okay? For instance, this right here would be, these 2 circles here would be an example, because when both of those drawings, and notice that. So we'll go ahead and fill in this box. This is an example of tangent circles, because they are sharing or touching at one point. Okay. Concentric circles. Concentric circles are an example of circles that are sharing the same center. circles that share the same center. And a common tangent would be this example right here, because both of those circles are sharing not only the same point but the same tangent line. And we did not fill in this last box. Okay, this last box, or this first box right here that I don't have anything in, this is an example of coplanar. Okay, because if these two circles are sharing these 2 points, then don't the circles have to be, if I drew a plane right there, aren't they sharing the same plane? So there's your example of coplanar circles. So let's do this example too. Identifying common tangents. Tell how many common tangents the circles have and draw them. Use blue to indicate common external tangents and red to indicate common internal tangents. Now, if you don't have different colors, draw your lines and then put an I next to that line or an E next to that line. E means external or outside, and I would be your internal tangent. Well, when you look at these two circles, there's not going to be anything internal, okay? But they do have some possibilities for external. For instance, and I'll go ahead and use my blue since I have blue. But for instance, if I had that right there, there's one tangent line, okay? And there's another example. It's touching right there, and it's touching right there. And that would be it. And so, if you don't have a colored pen, you could write the letter E for external. There's two external tangents. Okay. The next one, B. Okay. There's really, you've got that one right there. You're only touching with that. You still have those, just like in the first drawing, and you have that other one. Oops, that kind of messed up there. There we go. Try to fix it. Touching right there, touching at that point, and that point. Okay. And the last one. Well, you have your two externals. I know I kind of got them inside the circle, but it's kind of hard to be exact on this pad. Okay. And is there an internal tangent there? No, there's not. Always just have an external. Alright, so we're going to go ahead and skip 3, 4, and 5 to the next. Okay, this is really the meat of the lesson to me, besides the first page where we defined what our chords and our secant lines and that kind of stuff. But is what a tangent line does. There's two theorems here, okay? And these are things that you need to refer to whenever you do your homework, a bunch, okay? The first thing, a tangent line to a circle. If you're told that you have a tangent line, for instance, this blue line right here, this line M, that is a tangent line. P is the point of tangency, okay? Well, it says in this theorem, it says in a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle at its endpoint. So what they're saying is QP is the radius of the circle. Well, P is the point of tangency of the tangent line. Well, since it's a tangent line, then it has to be perpendicular, so it's making a right angle. Okay. Then the next theorem says the external tangent congruence theorem, and what it's saying is if you have two tangent segments, for instance right here, RS is a tangent segment, so there's one, and TS is a tangent segment, but both of those segments, RS and TS, notice what they both have common. Well, aren't they both sharing this same external point? Remember, external means outside. They're both sharing that same point. Well, they're both tangent lines. they share the same point, S, so they're congruent. That's what they're talking about. So if RS equals 10, TS equals 10. Why? Because they're both tangent lines and they share the same outside external point. So let's try to use these two theorems on the next couple of examples. The first one, they want us to verify that ST, this segment here that is 35, they want us to verify that it's a tangent line. In other words, we're going to verify that T is the point of tangency. Well, remember what the 10.1 theorem said? It said if it's a tangent line, then at the point of tangency is perpendicular. In other words, what that would mean is that this would have to be making a right angle right there, because isn't TP the radius? It is. Well, that means we have these three side measures of this triangle. Well, if it's a right triangle, that would mean T would be the point of tangency. It would be a tangent line. Well, how can we prove that this is a right triangle? Now let's think what we did with right triangles. How can we prove that this triangle STP is a right triangle? The Pythagorean theorem. I'm going to take my legs, 35, plus my other leg, 12, I'm going to square it, and I'm going to set that equal to the hypotenuse, which is 37, and I'm going to square that. Now, I'm not going to finish this problem, you are. And if I find out that the two legs squared and added equals the hypotenuse squared, then it is a right triangle, which means that that is the point of tangency, and so ST is a tangent line. So you guys find out if I have the three links that would make a right triangle. Alright, so now let's go down to example 4. Okay, finding the radius. Okay, so you look at this, looks kind of taxing. We don't know what CB is, and we know what a part of AC is. We know from point A to the circle is 50, but we don't know the rest. Okay, well, let's think about this. Okay, if AB is a tangent line, and how do I know AB is a tangent line? Because of this statement right here, that B is the point of tangency. Well, so that would mean that this is a tangent line, because B is the point of tangency. That also means that if B is the point of tangency, that's forming a right angle with that radius. So I know I have a right triangle. We'll set this information up just like you would using the Pythagorean theorem. So one of my legs is 80. Square that. Then my other leg is R. I square that. Okay. So what I've taken care of is I've used that, and I've used that R. Those are my two legs. Now I'm going to switch to black. Well, these two things here make the hypotenuse. In other words, 50 plus R, whatever R is, and that's going to be squared. Okay, so I would work this out. 80 squared would be 6,400. That's still R squared. Remember, this right here, this 50 plus R would mean I've got 50 plus R times 50 plus R. Okay. Well, 50 times 50 is 2,500. Then R times R would be R squared. And then in the middle, I would have R times 50, which is 50R. And then I'd have another 50R. So 50 and 50 is 100R. Okay. And so now, this is what I have over here. I have 2,500 plus 100R plus R squared. Alright, well, let's start moving stuff around. First thing I know I can move this 2,500. So I would subtract 2,500 from the 6,400. Okay, and so let's see here, what would we get? I don't have my calculator with me, so bear with me. So it's going to give me 14 minus 5 is 9, and then 5 minus 2 is 3, and so I have 3,900. So now I have 3,900 or 3,900 plus r squared plus 100, oops, is equal to 100r plus r squared. Okay, so now let's see. I bet I can do something with these r squareds. I'm going to subtract this r squared over there. Well, don't those cancel each other out? So now what I'm left at, I'm going to move up here and I'm going to have red. Now I've got 3,900 equals 100r. Well, I got to get r by itself, so don't I divide by 100? Okay. And so when I divide that, I find out that r equals what? 39. So I just found what r equals. R equals 39. Okay. And so now I know what the radius is. The radius is 39. Alright. I'm going to do one more example with you. Okay. This has to do with the second theorem that you had. They tell you here that RS is tangent to circle C at S, so S is a point of tangency. Then they tell you that RT is also a tangent line at T, so S and T are points of tangency. And don't both of the tangent lines share the same outside point R? Well, that second theorem we had is if we have two tangent lines that share the same external point, they're congruent. In other words, RS is equal or congruent to RT. Well, RS equals 28. RT right now equals 3x plus 4, but don't those two things have to equal each other? Well, I just need to solve for x. So I subtract 4. Right? So I'm left 24 on that side. I still have 3x. And now what would I do with that 3? What is 3 doing to x? Being multiplied. I'll divide by 3. And I find that x equals 8. And I'm done because that's all they asked me to find. So I'm moving down. Alright. So what I'm going to do is I want you guys to do 6, 7, and 8 yourselves. When you have an answer, raise your hand and have the substitute come and check and see if you got it right. If you get stuck, also raise your hand. I'm kind of going to give you some hints though. On this one, on number 6, okay, is DE a tangent line? Well, remember, for a line to be tangent, if it's the point of tangency is touching the radius, then it has to be perpendicular to the circle. So that means we have to have a right angle right there. So we need to see if those three measures make a right triangle. Hint, a squared plus b squared equals c squared. Okay. Number 7 is just like the problem that we did on the previous page. Remember we had the r's? Okay. Again, the hint is that this is a right angle. And then the last problem, number 8, your hint is this, is they tell you that M and N are points of tangency. Well, don't both M and N, don't they share this same point right here? So isn't this segment congruent to that segment? So doesn't that mean that these two things I'm circling in blue, aren't they equal to each other? Just remember that the two blue circles are equal and congruent to each other. Okay, and that will help you out. So go ahead and do those 3 problems and see when you have your answer. Ask the sub to come and check. Once you're finished with your notes, okay, go ahead and begin the assignment that is attached. Okay, make sure on your next class period, whether it's that you turn in your notes and you turn in the assignment as well. Okay.